This is the second video for worksheet 9.9. We're going to look at number 7, which is considering this right triangle and the angle theta right here. If sine of theta is 3/5, so we're going to be using SOHCAHTOA. Sine of theta is the opposite over the hypotenuse relative to this angle theta. So opposite is 3, hypotenuse is 5. And to find the third side of the triangle, if you know your Pythagorean triples, you can fill it in. If you don't know, you can use the Pythagorean theorem. So a squared plus b squared equals c squared. Okay, so 9 plus b squared is equal to 25. B squared will be equal to 16, so this missing side is 4. Now that we have all of the sides, we can find any of the trig functions. So cosine of theta is adjacent over hypotenuse, 4/5. Tangent of theta is opposite over adjacent, so 3/4. Secant is the reciprocal of cosine, which would just be 5/4. Cosecant is the reciprocal of sine, which is 5/3. And cotangent is the reciprocal of tangent, which is 4/3. Let's look at one example where the right triangle is not drawn for you. In this case, we're given a point on the terminal side of angle theta. Terminal side of an angle is the side where the angle stops. So this angle theta starts here at 0 and goes all the way until the terminal side right here. It's impossible to draw a triangle with that angle theta because this angle is obviously more than 180 degrees. So this is where the concept of a reference angle comes in useful, so that we can draw a triangle to solve all of these trig functions. So the reference angle is defined as the positive acute angle between this terminal side and the x-axis. So using that acute angle, you can call it anything you want. I'm just going to call that angle alpha. We can draw a triangle with this reference angle, a right triangle. To find the lengths of the sides of this right triangle, we need to use the point that's given. In the x direction, we're at -6. In the y direction, we're at -8. And again, if you know your Pythagorean triples, we know 3, 4, 5 is a Pythagorean triple. This is twice the size, so 6, 8, 10. And using this triangle and using the reference angle here, we can find all of the trig functions for that angle theta. So cosine of theta is the same as the cosine of alpha, adjacent over hypotenuse, and again we're just using SOHCAHTOA here. And the sign matters, the positive versus the negative, because we're in this quadrant, so sine and cosine are both going to be negative. Cosine is adjacent over hypotenuse, -6/10, which reduced would be -3/5. Sine is opposite over hypotenuse, so from this reference angle it would be -8/10, which reduces to -4/5. Tangent is opposite over adjacent, so this would be -8/-6. Tangent ends up being positive because you're dividing a negative by a negative. Now we're just looking at the reciprocal trig function. Secant is the reciprocal of cosine, so the negative stays, but it will be 5/3. Cosecant is the reciprocal of sine. The negative stays, but it'll be 5/4. And cotangent is the reciprocal of tangent.